Welcome. This video introduces the idea of multi-threading using BYOB. So, multi-threading is when we have multiple threads of execution. So a thread of execution is just a sequence of steps, basically a mini program that's going to run in parallel with other threads, with other mini programs. Why would we want this? Well, imagine we've got a video game, and we've got a lot of jobs that need to happen. We need to play some sounds, we need to draw to the screen and redraw what's happening for the next frame, we need to collect information from the mouse and the keyboard, we need to do calculations to figure out what all the characters in the game should be doing, the artificial intelligence. Right? There's lots of distinct jobs. And on a modern processor, there are lots of processing cores. So if we can split our program, our big program, the game, up into multiple separate jobs, threads of execution, it can be working on some of those jobs on different processing cores of our processor, so that we can be doing some drawing at the same time we're playing a sound, at the same time we're doing calculations for the AI. So we're going to go look at this in BYOB. I've got a couple different jobs set up for this one sprite. Right, so we don't have kind of multiple programs running. We've just got this one sprite who's going to be doing everything for us. And right now I've got when A key is pressed, forever say A for 1 second, and then wait for 1 second. So if I press A, he says A, waits, and he just keeps doing that forever. And you can see this block is kind of locked up because he's kind of now stuck doing that job. But if I hit A again, nothing really changes, right? He just keeps, I'm hitting A over and over and over, and he just keeps on doing his job. So let's stop this and modify it. So I'm going to take that forever and put it inside this launch block. So what the launch block says is go start a separate thread, a separate sequence of steps that can run at the same time anything else can, and we're going to have this forever run in that separate thread. So it's almost like having a separate character who's going to execute this code for us. So I'm going to hit A. Right. Nothing all that different. Now I'm going to hit A again. And it still looks pretty much the same. I'm going to hit A about 4 or 5 more times. Now it's pretty obvious something different is happening. Getting these A's flashing. There's not as much wait time anymore. What's happening is I've got about 5 copies of this code running. And so one copy of the code says A, and then another one immediately jumps in and says A, and so that's why it flashes. And because they're all still taking their wait time after they say A, but chances are, well, one of them's waiting, someone else is busy saying A, so we don't end up with as much time where the character's saying nothing at all. Right? And I could start introducing some B's, so if I hit B 1 time, right, if we watch closely, I see B flicker in there briefly, but almost immediately it's wiped out by one of the A's, which is not too surprising because there's about 5 copies of this code running and 1 copy of this code running, so we don't see B that often. If I hit B a bunch of times, right, now he's hardly ever waiting. He's pretty much always saying something, and we see a lot more B's now because I've probably got about 10 B's copies of the B code running and just 1 copy of the A code running. So this character at that point is running about 15 threads, 15 separate programs. Now BYOB doesn't actually run those on different processing cores, but it just does the time slicing between each job and makes it look like it's running all of those jobs at the same time. We can see another example of that over on this code on the left. So when the flag is clicked, we're going to point in direction 90, jump to the middle, set threads. So we've got a counter this time to keep track of how many threads there are, to 0. And we're going to say go. And then we're going to start just turning in a circle, spinning around. When we receive the go signal, we're going to change threads by 1. So we're going to mark that we've seen one, that we've started up 1 thread. And we're going to launch this separate thread that just starts moving forward forever. So I'm going to hit the flag, and we'll kind of watch what happens. All right, so at this point we've got 1 thread running. This main script is running, and it's locked into just turning forever. But at the same time, because it sent this go signal, we started up a separate thread that launched this other job of, okay, keep moving forward. Well, if we move forward at the same time we're turning, well, we end up doing a circle like this. Now, if I hit the space, it's going to broadcast another go signal, which will add a second thread, and we'll start up a second copy of this job. So I'm going to do that. You can see he's still turning in a circle, but now it's a bigger circle. Why? Well, there's two threads that are running this code that are moving forward 5. So basically, we're moving forward twice as fast as we used to be. Right? We're moving forward. We've got two jobs that are trying to move forward, one job that's turning us clockwise. And every time I hit space, so I go make a third thread, we get a little bit bigger circle because now we've got more and more copies of the code running that are trying to run forward. And fewer, well, the same number, one job that's trying to turn, but it's kind of being more and more overwhelmed by the code that is trying to run us forward. So we'll always have a circle, but it'll be a kind of progressively larger and larger and larger circle.